Hey guys, so this video is going to focus on partial fraction decomposition. So partial fraction decomposition problems tend to be just a little bit like lengthy, so bear with me when it comes to these examples here. So we're going to work through two of them. So partial fraction decomposition kind of comes from backtracking a technique when it comes to math here. So kind of pretend, very basic example here, that we were adding two different fractions together, right? And we get some answer, right? Some fractional answer over here. What partial fraction decomposition is it's going from that answer and backtracking and decomposing it, splitting it apart into its separate fractions. So that's kind of what we're doing here when we're working through this kind of example. So the first thing that we need to do for partial fraction decomposition is first we need to make sure that our example here is completely factored. Okay, so if we take a look at our example here, there's nothing to factor in the numerator, but we can see about factoring our denominator here. So I'm going to move over the numerator here, and we're going to focus on this denominator since I see that we have this trinomial that we're going to factor. And I'm going to try and factor this trinomial using what I call reverse FOIL. So when we do this factoring here, right, we're looking at x squared, and we know that x squared factors to an x times an x. Then we're looking at the 24, and we're looking for what multiplies to get 24, but adds or subtracts to get 5. So let's see, we can use 3 and 8 for our numbers here. 3 times 8 is 24. 8 minus 3 does give us a 5. So looking at our signs here, if your last term is negative, that tells us we're going to have different signs for our factors. But remember that whatever sign your middle term has, that must go with the bigger number, which means the minus has to go with a 3 here. So then what we have to do at this point is we're going to take our rational expression here, and we are going to set this equal to a new fraction. And what that new fraction is going to look like is we're going to assign a letter for our numerators, A, B, C, D, and so on, based off how many different factors you have in your denominator. So it's one letter per denominator. So since I have one letter per factor in the denominator. So the way that works is we're going to start with the letter A, and we're going to put it over our first factor of x minus 3. And then we're going to say plus B, and we're going to put it over our next factor of x plus 8. Had we had a third factor, we would say plus C over that next factor, and so on. So what we're trying to do is we're trying to figure out what these numerators are going to be, because remember, we're trying to take our original equation and split it up and see what it might have looked like before. Okay, so this is our new equation that we are going to work with here. So the whole x minus 25 over the x minus 3 times x plus 8 is equal to all of this over here on the right-hand side. So this is what we need to solve. Okay. So in order to solve this equation here, because of all the fractions, because of all the factors we have in the denominator, so the way to solve this kind of problem here is by multiplying the entire equation by the common denominator. Alright, so what we need to do is we need to find the common denominator of this entire problem. Alright, well, the common denominator is just the x minus 3 times the x plus 8. So we are going to multiply the entire equation by x minus 3 times x plus 8. Now, so this is going to be distributed to 1, 2, 3 terms that we have in our equation. During the first multiplication, so multiplying by our x minus 25 over the x minus 3 times x plus 8, the x minus 3 and the x plus 8 down in this denominator cancels with the x minus 3 and the x plus 8 over here, leaving us with x minus 25. For our middle multiplication that we have here, the a over x minus 3 times this the x minus 3's are going to cancel out, leaving us with this a times this x plus 8. Plus b over x plus 8 times this. The x plus 8's are going to cancel, leaving me with b times x minus 3. At this point here, we need to do a little bit of cleanup in our problem here. So I'm going to drop down the x minus 25, and I'm going to multiply. I'm going to distribute the a and the b out here. So a times x gives us ax. A times 8 gives us 8a. Plus b times x is bx. And then we have negative 3 times b gives us negative 3b here. Our next step after this is what we want to do is we want to rearrange the right-hand side of our equation and group it to where we have similar terms together. And what I mean by that is I'm going to group together my x terms, and then I'm going to group together essentially my constant terms almost. So we have x minus 25 is equal to ax plus bx, and then we have the 8a minus the 3b. And now what we're going to do here is essentially we're going to set up a couple of equations to try and help us to solve this thing. We're going to create a system of equations, and this is how you do that. So you take a look at the left-hand side. You have an x term, and then you have a constant term. So what we're going to do is we're going to take something from the left, set it equal to something for the right for our x terms, and then we're going to do the same thing for the constant term. So we're going to come up with two equations. So this is how that works. We're going to take our x term here. So this is just x, or more specifically a 1x. What we're going to do is we're going to take the coefficient of our x terms on the left-hand side and set it equal to the coefficients of our x term on the right-hand side. So the coefficient of our x term on the left-hand side is a 1. We're going to set that equal to the coefficients of our x terms on the right-hand side, which is a and b. So that's an a plus ab. And that's my first equation. So we're only looking at the x terms when we do this. So we did this one with this a plus b. And then we're going to do the same thing, create a separate equation, but for our constant terms. So on the left-hand side, we have this minus 25. And we're going to set that equal to our constant terms over here on the right-hand side, which is a positive 8a and then a minus 3b. So these two equations right here are going to be the equations that I'm going to be working with. Okay, so essentially we've created a system of equations that we're going to use to solve. Okay, so let me use the space over here. So we're going to solve this system of equations. 1 is equal to a plus b. Negative 25 is equal to 8a minus 3b. And what I'm going to do is I'm going to use elimination method in order to solve this. So elimination method is the method where you want to add both of your equations together in the hopes of canceling one of your variables out. So what I'm going to do is I'm going to work on canceling my b variables here, since those have the smallest number. I see that my b variable in the bottom equation is a negative 3. So what I'm actually looking for in my first equation over here is I want to create this to be a positive 3b. Again, if you're not familiar with solving systems by elimination method, I would go back and review that concept real quick if you need a little bit deeper explanation with it. But otherwise, what I'm going to do is I'm going to take my top equation and multiply this by a 3. And when I do that, when I distribute a 3 to everything, 1 times 3 is 3, is equal to 3 times a gives us 3a, 3 times b gives us 3b. And I'm just going to drop down the bottom equation here. And what I'm now going to do is I'm going to add both of these equations together in the hopes that something is going to cancel. 3 plus a negative 25 gives me a negative 22 is equal to 3a plus 8a gives me an 11a. And then 3b plus negative 3b, that actually cancels. That is what I'm looking for. So I'm left with this simple equation. So we're solving this one here for a. So in order to solve for a, all we have to do is divide both sides by 11. So 11 divided by 11 cancels, gives me an a. Negative 22 divided by 11 is a 2. So we know that a is equal to 2. And if we know that a is equal to 2, we can take any one of our equations and plug that in. So what I'm going to do is I'm going to take our basic equation here, 1 is equal to a plus b, and I'm going to plug in 2 for a. So I just realized that this 2 is supposed to be a negative 2. I'm so sorry that I left that negative off. Negative 22 divided by 11 is a negative 2. So that when we backtrack and substitute here, again, I'm going to use the 1 is equal to a plus b right over here. And what we're going to do is we're going to plug in negative 2 in for a so that we can solve for b. So in order to solve for b, all we have to do is add 2 on both sides, giving us that b is equal to 3. So now that we know the value of a and we know the value of b, we can go back and input them into our fractions here, which will give us our final partial fraction decomposition for this problem. So what that's going to look like is it's going to look like this. So it's going to look like our a over x minus 3, but now we know that a is negative 2, and we put that over x minus 3. And then plus our b, which is 3, over the x plus 8. So this is what the partial fraction decomposition looks like for this problem. So you can see it was a little bit of a lengthy problem. But that's okay. You know, a lot of times in math, you know, unfortunately we have to deal with very multi-step type of problems in order to work with. Otherwise, let's try and work on example B and see what we get for that. All right, so looking at example B. So remember, the first thing that we want to do is we want to make sure that this is factored, specifically in the denominator. We need to make sure the denominator is factored. So I see that this is kind of already factored into two different things here. We have the x minus 1 and the x squared plus x plus 1. Now that trinomial that we have in the denominator, I would double check that and check to see if that factors any further. But if we did try and factor this, like x times x equals x squared, the only way to get 1 is 1 plus 1 times 1. Everything is positive here, so everything should be positive in the factors. But if we multiplied this out, we'd actually get x squared plus 2x plus 1, which is not the same thing that what we have here in this trinomial. So that actually means that this cannot factor. So our denominator is already factored. So when we split up our fractions like we did over here, right, it's a over the first factor, b over the second factor, and so on. There is a slight difference with this example here. So I'm going to move this up a little bit here when I set this equal. So this is going to be a over the x minus 1. And before I set up my second fraction, what we need to keep in mind here is my second factor is a quadratic factor here. And what that means is because it's a quadratic factor, because it has a degree of 2, right, our highest power is 2, we need to have two different letters in our numerator to kind of go along with that. So we're not just going to say b over the x squared plus x plus 1. We're going to call that bx plus c over the x squared plus x plus 1. And again, we're doing this because that's a quadratic factor. Had this just been like an x plus 5 or something else like that, I would have left it b over that. But because it's not, because it's a quadratic, I have to have two letters here to go along with the power of a 2 there. Okay, so let me go ahead and move this problem up a little bit just so that I have more room to work with here, so that we can do our multiplication. Because remember, after you split this up into its fractions here, the next step says to multiply the entire equation by the lowest common denominator. That lowest common denominator is the x minus 1 times the x squared plus x plus 1. So again, that means we're going to do 3 multiplications here. So times our original times the a times the bx plus c. First multiplication here, the x minus 1 and the x squared plus x plus 1 cancels with the same thing we have in the numerator here, leaving us with 10x plus 2 is equal to x minus 1 will cancel with this x minus 1, leaving us with a times the x squared plus x plus 1. Plus, here we're going to have the x squared plus x plus 1 cancel with the x squared plus x plus 1 over here, which means that we have the bx plus c times the x minus 1. So this is the multiplication that we're doing here. Okay, so really quickly, I'm going to use the FOIL method to multiply this out. F stands for first, so that's bx times x, so that's bx squared. Then we do outside, bx times minus 1 is a negative bx. Inside is c times x. And then last is c times negative 1, so that gives us a negative c. So I'm just going to bring that right back over here with the rest of my equation. So then we need to do some cleanup here because we still need to distribute this a out to everything. So let's go ahead and take care of that. A times x squared is ax squared. A times x is ax. A times 1 gives us a. And drop everything else down. Now let's rearrange this to make sure that all of our common terms or all of our like terms are together. So we're going to group our x squared terms. We're going to group our x to the first power terms, and then we're going to group our constants. So the left-hand side is still going to stay the same. That just keeps dropping down. On the right-hand side, we have ax squared plus bx squared. And then our x to the first power terms are ax minus bx plus cx. And then our constants are the plus a minus c. So because this is quadratic, so we have x squared terms, x to the first power, then constant, that means we're going to set up 3 different equations that we're going to use to solve. Now, this is how those 3 equations are going to look like, because remember, we're essentially matching up the coefficients of each. The coefficients of the x squared on the left with the coefficients of the x squared on the right, coefficients of the x to the first on the left with the coefficients of x to the first on the right. All right, so we're looking at these coefficients, then these coefficients, then these. Now, on the left-hand side, we don't have an x squared. But we still need to match something up with this ax squared plus bx squared. So if we don't have an x squared, that's kind of like saying 0x squared. Okay, I mean, we don't have any x squared terms. We're going to make an x squared by putting in 0x squared. What that means is its coefficient 0 is going to match up with the coefficients of the x squared terms on the right side. So 0 is equal to the a plus b. The coefficients of our x to the first power, so that is 10 on the left-hand side, and on the right-hand side we have a minus b plus c. And then our constant terms, on the left we have 2, and on the right-hand side we have a minus c. So this is the system of equations that we need to solve for here. So taking a look at this system, let's see, we can't really use elimination method here just because I don't see any 2 equations that have the same letters. Like these have ABs, but this has AC. Those aren't the same thing, right? And then this middle one has all 3 of them. So what I'm going to do is I'm going to do a little playing around with the equations here. So we have the equation 0 is equal to a plus b. What I'm going to do is I'm going to subtract b on both sides, making this be negative b. I'm not sure if you can see that. We get negative b is equal to a. And so second equation here, if I take this a here and plug in negative b instead, that means that a is going to be negative b, and then I have another negative b plus c, which means I'm left with 10 is equal to, well, negative b minus b gives me negative 2b plus c. If I do the same thing for the third equation, instead of a here, that means I'm plugging in a negative b instead. Okay, so now I've been able to create the second and third equation and now put them to where I now have a's and b's for each. B's and c's for each one of these. Now I can use elimination method in order to solve here. And I can go ahead and add these two equations together. 10 plus 2 gives us 12. Negative 2b plus negative b is a negative 3b. And then a positive c plus a negative c cancels out. So here we have 12 is equal to negative 3b. All we have to do is divide both sides by negative 3, and we get that b is equal to negative 4. So what we can do here is, now that we know that b is equal to negative 4, we can backtrack and we can figure out what some of the other values are equal to. Okay, so now we need to try and figure out what is a and what is c. So I'm going to go back up to this first equation here. 0 is equal to a plus b. We now know that b is equal to negative 4. So if b is equal to negative 4 and we plug it in there, all we have to do is add 4 to both sides, and we get that a is equal to a positive 4. So now that we know what a and b are both equal to, we can either take the second or the third equation and backtrack and plug in. I'm going to take the third equation that says that 2 is equal to a minus c. Now that we know that a is equal to 4, we can plug that right in. Which means if we're solving for c, we subtract 4 on both sides to get that negative c is equal to a negative 2. And dividing out the coefficient, we get that c is equal to 2. So I know that was a lot of work to get there, but we're finally ready to set up our partial fraction decomposition of this example here. So the way that that's going to look like is this. So that is going to equal to the a over the x minus 1, except now we know that a is equal to 4, so that is 4 over x minus 1. But remember that b is equal to negative 4, so that's negative 4x plus c, and c is a 2. So our numerator there is a negative 4x plus 2 over the x squared plus x plus 1. And that is what the solution to example B looks like. So otherwise, that's it for this video.